Okay, so this is the last video in the series about fractions. Let's see. So I think it's video 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, this is the 12th video. This is the last one in the series of fractions. So at this point, you know how to simplify fractions. You know how to add, subtract, multiply, and divide. So what we'll do in this video is we'll talk very briefly about how to deal with exponents, so like fractions raised to an exponent, and then we will do the order of operations. So let me get my hair up. I think better when it's pulled back. Let's go. Okay, so first of all, let's talk very briefly about exponents with fractions for bases. Okay, now you'd have to go way back to previous videos, like way back, to get videos on how exponents work in general. But basically, if I have a to the n power, a is the base, n is the exponent. The base is what's being multiplied repeatedly, because at the end of the day, exponents are really just used to represent repeated multiplication. Okay, so the base is what's being multiplied repeatedly, and the exponent tells us how many times to multiply the base by itself. Okay, now if I were to have a fraction, let's say I had 1/2, and I wanted to square it, I basically have to square each piece of the fraction. So this is the same as 1 squared over 2 squared, or 1/4. You could also think of it in that sense of just repeated multiplication. 1/2 squared is the same as 1/2 times 1/2. I, in the numerator, have 1 times 1, or 1 squared. In the denominator, I have 2 times 2, or 2 squared. No matter what, you get 1/4. So just remember, if I have the fraction a over b, and I raise it to the n power, it is the same as a to the n over b to the n. Okay, so keep that in mind, because with the order of operations, we will have a few examples where fractions are raised to different powers. Okay, now to review, order of operations. Now, the order of operations comes up with whole numbers, it comes up with fractions, decimals, integers. It can come up with anything, okay? The order of operations itself does not change, okay? Just the numbers that we're working with do. So like in the past, we learned how to deal with the order of operations where we just had whole numbers. Now we're going to do the exact same order of operations, but now we're dealing with fractions, okay? So the steps. The first step is to deal with parentheses or grouping symbols. Grouping symbols is kind of a broader term. So grouping symbols could just be regular parentheses, brackets, braces. You could also have absolute value bars. You could have a radical, a square root, okay? So any of those could be considered grouping symbols. So what we would do is we would take care of what's inside grouping symbols. If you ever have nested grouping symbols, where you have grouping symbols inside grouping symbols, you work from the inside out. Second, you deal with exponents. Now, some people will also include the square roots down here. Okay, so if you don't take care of any square roots in the first step, you definitely have to take care of them in the second step. The third step is to take care of all multiplication and division, and we work from left to right. So that doesn't mean do the multiplication and then do the division. Whichever one comes first, you do. So if in your problem multiplication comes first and then division comes second, multiplication first, then division. If the reverse is true, and in your problem division shows up first, you take care of the division first. Fourth step is addition and subtraction. And it's just like multiplication and division. We work from left to right. Now, some people remember PEMDAS Or please excuse my dear Aunt Sally. And that is fine. Both of these are perfectly fine. They help you remember the steps. Just be cautious. It's not multiplication and then division. It's not addition and then subtraction. It's multiplication and division at the same time, addition and subtraction at the same time, just working from left to right. Okay, so let's look at some examples. I've got several here. I think I've got 12. We'll see how it goes. So for the first example, I have 9/8 divided by 6/7 times 11/4. Now, hopefully you remember from our videos on multiplying and dividing that when you're dividing fractions, you really have to convert it to multiplication. So since this problem only has multiplication and division, I'm going to go ahead and convert my division to multiplication, and we're just going to go from there. So with this part right here, I'm going to keep the 9/8. I'm going to multiply by the reciprocal of 6/7, which is 7/6. And then just don't forget you still have 11/4. All right. So at this point, I would want to look to see if I have any common factors, top versus bottom. I noticed the 9 and the 6 have a 3 in common. So 9 divided by 3 is 3. 6 divided by 3 is 2. Now, if I look across, I have 3s, 7s, and 11s in the numerator. None of those factors will reduce the 8s, the 4s, and the 2s in the denominator. So I'm done simplifying. I need to multiply across. So I've got 3 times 7 times 11 all over 8 times 2 times 4. You could do some side work. You could use a calculator for the multiplication. So 3 times 7 times 11 is 231. 8 times 2 times 4. Well, 2 times 4 is 8. 8 times 8 is 64. You could absolutely leave this improper if you wanted to. You could write it as a mixed number if you wanted to. It's up to you. Again, rules for that. Generally, the improper fraction is perfectly fine. Times that you would want to really strongly consider the mixed number would be if you're dealing with a word problem, if you're dealing with any kind of measurement conversion or geometry, if the directions obviously specify you that you write your answer as a mixed number, or if you start with mixed numbers. Since we didn't start with mixed numbers here, you really could just leave it as 231/64. But if you did want to practice, we would want to know how many times 231 could be divided by 64. Well, 64 goes into 231 3 full times. All right. And then if we subtract that product, we get 39 left over. So we get 3 and 39/64. That wasn't the easiest one in the whole wide world to convert to a mixed number. So I don't want you ever to rely on your calculator completely, but you can use your calculator for those little, I guess those little quick problems, those little operations that you need to do, just to save you some time. Okay, so there we have it. Again, don't rely on your calculator, but certainly use it for just quick calculations, okay? Like dividing 231 by 64, no big deal, okay? Let's move on to a new problem. So for this problem, we have 3/5 times 1/8 plus 1/4 times 1/5, okay? So in this problem, I've got multiplication and addition. I need to take care of the multiplications first. So I've got this right here that I need to work on, and then this right here that I need to work on. Okay, so let's look at 3/5 times 1/8. We ignore the rest of the problem. So when I look at 3/5 times 1/8, I have no common factors top to bottom. In the numerator, I have just 3. The denominator, I have 5 and 8. None of those are common, so I just multiply across. I get 3 times 1 over 5 times 8. All right. Now I'm going to look at 1/4 times 1/5. I'm going to ignore the rest of the problem. So again, in the numerators, I just have 1s. There's nothing I can simplify with the denominator, so I multiply across and I get 1/20. Okay. Now we have to do addition. And remember, addition is where it's a bit more complicated. So we have to find the LCD. And remember those shortcuts I showed you for finding the LCD. If one of your denominators, so I've got just the two fractions here, if one denominator divides into the other denominator evenly, the bigger denominator is the LCD. So I noticed that 20 divides into 40 evenly. So that tells me my LCD, whoops, I can't even write LCD. That tells me my LCD is 40, okay? So I don't have to rewrite 3/40, but I do need to rewrite 1/20. So what would I multiply 20 by to get 40? Well, 2. So I would multiply top and bottom of this fraction by 2, remember? This is just a weird version of 1. So I'm not changing the value of 1/20. Remember, when we multiply by 1, it doesn't change the value of the number you start with. But in this case, while it's not changing the value of 1/20, it's changing the appearance of 1/20, okay? So rewrite the whole problem. I've got 3/40 plus, well, 1 times 2 is 2, 20 times 2 is 40. So I have 3/20 plus 2, I have 3/40 plus 2/40. I add my numerators, I get 5 over 40, and I definitely want to reduce. 5 goes into 40 and itself, so 5 into 5 is 1, 5 into 40 is 8. So our final answer here is 1/8. All right. So just take it nice and slow. If you need to have an area on your paper just for side work, do that. Be neat and organized. Okay, let's look at 1/7 to the third power times 2/3 to the second power. So we get to practice exponents. So remember, when you have a fraction in parentheses, it does need to be in parentheses, raised to a power, you just apply that power to both the numerator and the denominator. So I'm going to rewrite this a little bit. 1/7 to the third is just 1 to the third. 7 to the third. 2/3 squared is just 2 squared over 3 squared. All right. We want to go ahead and simplify. 1 to the third is just 1. 7 to the third is 343. That would be a good time where, the calculator would be reasonable. If you don't remember 7 to the third off the top of your head, use your calculator, but just don't rely on your calculator completely, okay? 2 to the second is 4. 3 to the second is 9. Now, 4 does not go into 9. 2 does not go into 9. 343 is not divisible by 3 or 4. So we can just multiply across. 1 times 4 is 4. 343 times 9 is 3,087. So it's a little bit of a messy answer, but there you have it. That's your final answer. Let's try some more. What if I had 2/3 times 1/8 plus 1/4 times 6? Okay. So in this case, we do have parentheses, and the parentheses are basically keeping an operation together. So in this example over here, the parentheses were not grouping symbols. The parentheses were really just saying, hey, this number is being raised to this power. But in this example right here, the parentheses are containing an addition problem. So these would be considered grouping symbols, okay? So looking just inside the parentheses, I need to find an LCD for 1/8 and 1/4, okay? And I just so happen to notice that 4 divides into 8 evenly. So that means the LCD here is 8. I don't have to rewrite 1/8, but I do need to rewrite 1/4, okay? So I would multiply top and bottom by 2. And now what I'm going to do is I'm going to rewrite the entire problem. So inside parentheses, I have 1/8 plus now 2/8 times 6. So I still need to take care of what's inside parentheses, but now I've got common denominators, so I can do that addition. So I get 2/3 times 3/8 times 6. And I'm going to go ahead and just write my 6 over 1 so that I have 3 complete fractions. Now notice I'm just multiplying. Okay, so I can look for any factors in the numerator that'll cancel any factors in the denominator. I notice right off I have 3's that cancel. Now, remember, a lot of times when we cancel a number, we're like, oh, it just disappears. It does not just disappear. It leaves a footprint behind of either a 1 or a 0. When you're multiplying and dividing, it leaves a footprint behind of a 1. I also noticed 2 and 8 have a common factor of 2. 2 divided by itself is 1. 8 divided by 2 is 4. Now, I'm going to go ahead and just clean up this problem because it's getting a little messy. I have one more simplification that I can do. All right. 6 and 4 have a 2 in common, so I want to divide both of those by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. And now I just multiply across. In the numerator, I have 1 times 1 times 3. In the denominator, I have 1 times 2 times 1, or 2. So your final answer is 3/2. If you prefer, or if the circumstances require it, you could write this as a mixed number. 2 goes into 3 once with 1 out of 2 left over. Not bad. Let's keep moving through my list. Okay, for the next problem, we have 5/2 plus 2/3 squared minus 3/8. Okay, now this set of parentheses is not classic grouping symbols. This set of parentheses is really just keeping the 2/3 together so that we know the whole 2/3 gets raised to the second power. So we're going to start by dealing with that exponent. All right. Now, when we rewrite this, we get 5/2 plus. Now, remember, 2/3 squared, you square the 2. So 2 squared is 4. 3 squared is 9. And we subtract. All right. So at this point, since I'm just adding and subtracting, I'm going to look for one global LCD. Okay. I'm not going to do an LCD for the 5 and the 9 and then come back and do a separate LCD for whatever that result is with the 8. I'm just going to do one global LCD. So if we do the LCD table, 2 is just 2. 9 could be written as 3 times 3. 8 could be written as 2 times 2 times 2. So I want to fill in the table. All right, 2 is just 2. 8, I can line up 1, 2 with the 2 that's already in the table, but then I have to start 2 new columns. Now the 3's in 9, we have to start new columns for both of them. Remember, once you have a number in a column, you can't put another type of number in that column. So the product for the value of each of these 5 columns is going to be the LCD. So I get a 2, 2, 2, and then a 3 and a 3 column. When I multiply this out, I get 2 times 2 times 2, which is 8. I get 3 times 3, which is 9. At the end of the day, LCD is 72. Okay. So what we're going to do is we're going to come back to 5/2, 4/9, 3/8, and we're going to rewrite each of these so that we have that LCD as the denominator. Remember, when you're adding and subtracting, you have to have a common denominator. So looking at my first denominator of 2, I would have to multiply it by 36 to get the LCD of 72. When I look at my next fraction, 4/9, I would have to multiply that denominator 9 by 8 to get 72. So top and bottom by 8. And then my final fraction, 3/8, I would have to multiply the 8 by 9 to get 72. So top and bottom by 9. Now, let's do a little work. 5 times 36 gives us 180 over 72. 4 times 8 gives us 32 over 72. And then 3 times 9 gives us 27 over 72. So now I have common denominators. I'm going to start by adding, and then I'm going to subtract. So right here, I have 180 plus 32. When I add those, and if you need to do side work, you can, I get 212 over 72. Now I want to subtract 27 over 72. And again, you can do some side work if you want to. All right, and you get, let's see, that's going to become a 12, a 0, so it'll be 5, 18, 185. So now we have 185 over 72. The first thing I would do is I would try to convert this to a mixed number and then reduce. So let's see, 185, 72 will go into that 2 times. All right. So 2 times 72 is 144. When we subtract that from 185, we get 41 left over. So it turns out 185 over 72 is reduced. So either of those would be perfectly acceptable answers. So 185 over 72 or 2 and 41 over 72. All right. Next up, let's see, we've got more with subtraction and multiplication. This one's actually super easy. It's got a little trick and then a property that you can apply. Well, no, I read it wrong. I lied to you completely. I fell into a trap. So at first I glanced at this and I was like, oh, 5/8 minus 5/8 is 0. 0 times 1/4 is 0. But that's not true because what did I do? I didn't follow my order of operations. I have to do the multiplication before I can do the subtraction. All right. So we have to multiply first. So we got to take care of this first, and then we'll do the subtraction. Okay. So ignoring everything in the problem except the 5/8 and the 1/4. I notice in the numerator I have a 5 that does not divide into 8 or 4, no common factors. I just multiply across. So I get 5/8 minus 5 over 32. All right, so now I need an LCD. And if I look at these denominators, I notice that 8 divides into 32 evenly. So that makes 32 the LCD. All right. So I don't need to rewrite 5 over 32, but I do need to rewrite 5/8. So what would I multiply 8 by to get 32? I really wish I was in the class because when I'm in the actual classroom, you all catch those little mistakes where I wrote LCD equals LCD instead of LCD equals 32. Bless my heart. Anyway, so what would I multiply this 8 by to get the LCD of 32? Well, 4. So I multiply top and bottom of the first fraction by 4. Let's rewrite everything. The first fraction becomes 20 over 32. From that, I want to subtract 5 over 32. I've got a common denominator now. I can subtract my numerators. So 20 minus 5 is 15 over 32. Now, 15 has factors of 15, 3, and 5. None of those go into 32. So this right here is your final answer. All right. Let's see. Let's do one with addition and division. So this time we have 2/3 plus 5 over 6 divided by 5 over 2. Okay. So according to the order of operations, again, we have to do the division before we do the addition. Okay. So we need to take care of this right here first. So I'm going to rewrite the whole problem because division has to be converted to multiplication. So the first fraction of 5/6 is going to stay the same. And then I'm going to multiply by the reciprocal of 5/2, which is 2/5. All right. So we're still just looking at the last two fractions here. I want to look to see if anything will cancel. And I do have some stuff that can cancel. 5s cancel, leaving behind the little footprints of 1. 2 and 6 have a common factor of 2, so I divide each of those, 2 and 6, by 2, and I get 2 into itself is 1, 6 divided by 2 is 3. So let's clean it up a little bit. I still have my 2/3 waiting patiently to be added, but then for the multiplication, I end up with just 1/3. Now, luckily, this doesn't happen too often, but luckily when we perform the order of operations, we end up with this last step of addition, and we already have common denominators. So I can go ahead and add my numerators. So 2 plus 1 is 3. Denominator is 3. And how does that simplify? Well, any number divided by itself is just 1. So we are done. All right. Let's try another one. So this one has division and multiplication. So I have 110 over 81 divided by 11 over 2 times 9 over 2. Now, this problem is just multiplication and division. So once I convert my division to multiplication, I can just multiply everything. So let's go ahead and look at this piece right here. We want to convert it to multiplication. So the first fraction stays the same. I multiply by the reciprocal of 11 halves. That gives me 2 over 11. And then don't forget your 9 halves over here. We just bring it down. Okay. So we want to look for common factors anywhere in the top. Since this is all multiplication, we can look at anything in the top with anything in the bottom. Okay. I notice right off the bat the 2's. Okay. The 2's cancel each other, leaving behind 1's. I also notice right off the bat the 9 and the 81. 9 and 81 share a common factor of 9. So 9 divided by itself is 1. 81 divided by 9 is 9. And finally, this may or may not be as obvious, but 110 is divisible by 11. So 11 divided by itself is 1. 110 divided by 11 is 10. All right, so I clean everything up. I can multiply across and I get 10 times 1, which is just 10. My denominator, I get 9 times 1, which is just 9. 9/10 is a perfectly acceptable answer. If you wanted to convert, we know that 9 will go into 10 one time. We'll have 1/9 left over. And that's it. So hopefully you're finding the order of operations to not be too bad. Let's do a few more. How about these two? These two are pretty straightforward. So let's say I have 1/3, that whole fraction squared. So these parentheses aren't really grouping symbols. They're just making sure you know the whole fraction is squared. And I then want to divide 8/9. All right. We do need to take care of the exponent first because exponents come before multiplication and division. Okay. So remember, if I take a fraction and I square it, I square each part of the fraction. So 1 squared is 1, 3 squared is 9. So I have 1/9 divided by 8/9. And remember, when you're dividing fractions, you really convert it to multiplication. So I get 1/9 times 9/8. And then we look to see if anything cancels, and we do have 9's that will cancel. So I'm left in the numerator with just 1 times 1. In the denominator, I'm left with 1 times 8. Piece of cake. All right. Let's do another one kind of like that, but we're going to have multiplication. So I have 1/4 times 2/3 squared. Okay. So I bring down my 1/4. I'm rewriting the whole problem, but when I rewrite the 2/3 squared, I'm going to go ahead and take care of the exponent. And just like in the previous example, remember, if I square a fraction, I just square both parts of the fraction. So 2 squared is 2 times 2 or 4. 3 squared is 3 times 3 or 9. So now I'm dealing with multiplication. I need to look for anything in the top and bottom that would cancel. I see right off the bat, I have 4's that'll cancel. That's it. I multiply across, I get 1 times 1 over 1 times 9. Piece of cake. Okay. Let's look. I've got 2 more examples. I don't know which one's better. Let me fix this line that's driving me nuts now that I see that it's really crooked. Well, that's still crooked, but maybe not as bad. Let's do this one. So I've got 3/8 plus 5/6. Oh, I'm looking at 2 problems. Let me fix that. So I've got 3/8 times 1/7, that's better, plus 1/8 divided by 7/3. Now, since these multiplication and division parts are separated by addition, I can kind of do them at the same time, okay? Because the addition separates them as almost 2 separate problems. So let's look at the multiplication first. And then even though I can kind of do the division at the same time, I'm going to still sort of separate them so we get each piece nice and worked out, okay? So looking at just 3/8 times 1/7, I'm going to ignore the rest of the problem completely, okay? 3/8 times 1/7, I have no common factors that I can divide out, so I'm just going to go ahead and multiply across. So I get 3 times 1 over 8 times 7, which is 56. Now to that, I'm going to add 1/8 divided by 7/3. And so for this step, I'm not going to do the whole problem. I'm just going to convert it to multiplication. So when I bring it down, I'm going to write it as 1/8 times the reciprocal of 7/3. Okay. So 3/56 stays. And then I want to go ahead and do this multiplication right here. So looking at 1/8 and 3/7, I have no common factors top to bottom. So I just multiply across. So I get 1 times 3, and then I get 8 times 7. Okay. And this happened once in a previous example. This does not happen a ton, but every now and then, as you work through the order of operations, you'll get to a final step that's addition or subtraction, and you already have common denominators, which is amazing because you can skip that whole LCD equivalent fraction step. So here we have a common denominator of 56. I want to go ahead and add my numerators. 3 plus 3 is 6. We want to look for common factors between 6 and 56, and they're both even, so that means they're at least divisible by 2. So 6 divided by 2 is 3. 56 divided by 2 is 28. Well, 3 does not go into 28, so our final answer here is 3/28. And that's it. All right. One more example, and I'm going to go ahead and move to another screen because I don't think I can fit it in what's left. So for this last example, I have 3/10 divided by, in parentheses, 1/5 plus 1/10 quantity squared. So I got a lot going on here. I've got parentheses, like legit grouping symbols, because inside those parentheses, I have an addition problem. I also have exponents, and then I have division. So we have to start with what's inside parentheses. So looking at 1/5 and 1/10, I noticed that 5 divides into 10 evenly. So that tells me my LCD is 10. Okay. I don't need to rewrite 1/10, but I do need to rewrite 1/5. So what would I multiply 5 by to get 10? Well, I would multiply by 2. So top and bottom by 2. And I'm going to rewrite the whole problem now. So I'm going to bring down my 3/10 divided by parentheses. And now I'm going to write that 1/5 as 2/10 plus 1/10 squared. So now 2/10 plus 1/10 is just 3/10 squared. Now, remember, when you square a fraction, like if the fraction's in parentheses with an exponent, that exponent gets applied to the numerator and the denominator. So this is 3/10 divided by, well, 3 squared is 9, 10 squared is 100. Okay. So I'm going to start going out here to the right just because I'm almost out of room. So I need to convert my division to multiplication. So 3/10 stays. And then I multiply by the reciprocal of 9/100ths, which is 100 ninths. All right. We need to look for stuff that'll cancel. I noticed right off the bat, 10 and 100 have a 10 in common. 10 divided by itself is 1. 100 divided by 10 is 10. 3 and 9 have a 3 in common. 3 divided by itself is 1. 9 divided by 3 is 3. We rewrite. So 1 times 10 is just 10. 1 times 3 is 3. That's a perfectly lovely answer. Or if you wanted to, we could say 3 goes into 10 3 times with 1/3 left over. And that's it. All right. So just a quick recap, exponents, if you have a fraction in parentheses with an exponent, the exponent is applied to the numerator and denominator. Okay. So as far as the order of operations goes, grouping symbols, that's any parentheses, brackets, braces. You could have absolute value bars. You could have square roots. Square root's kind of a weird one because it could happen in step 1 or 2. Step 2 is exponents or square roots. Third step is multiplication and division, working from left to right. Fourth step is addition and subtraction, again, working from left to right. And we did gobs of examples. Okay, I believe we had 12 examples total. Okay, so hopefully that gives you a decent overview. Let me check my phone. Okay, sorry about that. So hopefully that gives you a decent overview of order of operations. Now, this was a 12 video sequence, okay? So if you're coming to this 12th video and you haven't seen the first 11, it would be worth your time to go back and watch them. Now, if you've watched all 11 videos, kudos to you for getting through all this, because fractions are tough, okay? So a lot of people don't like fractions, and as soon as they show up in a math class, they just shut down, okay? Now, to be clear, fractions never did anything to you. You may not like them, but they didn't do anything to you. So try to get over your fear of fractions a little bit by just working with them. That's the best way to kind of tackle fractions, is just to start working on them. So scrap paper, you know, it doesn't have to be pretty, okay? Or you can go get, like, from the Dollar Tree, you can get those little whiteboards and whiteboard markers. Those are really nice to use. I've had students in the past that don't want to waste all their paper, but they don't really want to go and buy a whiteboard. So they get one of those 3-ring binders that has the clear pocket in the front. That clear pocket can act as a whiteboard. So you put just a piece of white paper in there and you can write on it with a dry erase marker. It wipes off with water. That works too. So just at some point, put pencil to paper or put marker to whiteboard or whatever the case may be, and just try these problems out, okay? So as you watch through all of these videos that I've made, don't just watch them blindly, actively participate. So as you watch the videos, hopefully you've had paper and pencil out, you've been working the problems with me. You can even write down the problems and work them out some other time. But at the end of the day, work the problems out, okay? So this is the end of the 12 video sequence on fractions. Next up, we're going to start a sequence on decimals. For the most part, students like decimals a lot more than fractions, okay? So good things are coming, all right? Best of luck.